take a look at one last example. C. F at theta is -1 plus 3 sine theta. If I actually graph this, if I put it in my calculator and graphed it, what I would notice is a couple of things have happened. One, this 3 is going to elongate the amplitude. It's going to make my amplitude 3. And this -1, which I could have actually put out at the end, is going to shift the graph down 1. I happen to put it in the front because I thought that would look a little bit different than what we've typically done. So if I think about what the sine function would look like, it would go up to 3 and down to -3. But then if I slide the whole thing down 1 unit, instead of going up to 3, it's going to go up to 2. And instead of going down to -3, it's going to go down to -4. That does not affect my period. My period's still 360 degrees or 2 pi radians. It will, however, affect my midline. And again, notice the graph goes up to 2, down to -4. And if I figure out where the halfway point is between +2 and -4, I'd learn it's -1, so the midline is y equals -1. You might notice looking at this equation, you might say, hey, is that this -1? And in fact it is. That I can actually read off the midline in this particular format, and so I can read off that it would be y equals -1. Just like I could read off the amplitude as the coefficient on the sine, made positive, which it already is, so my amplitude is 3. So, in general, if I have a function that looks like m plus a sine theta, the period is always going to be 360 degrees. If it's just sine of theta or sine of x, period's always going to be 360 degrees or 2 pi radians. The midline, so if I have m plus a sine theta, the midline is going to be m, so I'll get y equals m as the official equation. And the amplitude is always that coefficient of sine, but I did put absolute value on just to ensure that I have a positive amplitude, because remember, amplitude's a distance, so the amplitude must always be a positive number.